Now in this section, we're moving away from an abstract networking concept into a physical world. Media and cabling distribution just refers how network cables are physically planned, installed and organized in buildings and data centers. Even the best designed network will fail if the cabling is poorly installed. So cabling distribution focuses on cable path, termination points, patch panels, racks and cabinets. So a professional technician does not plug in cables. They follow standards so that networks are reliable, they are scalable and easy to maintain. I mean, if you've got poor cabling, it will causes signal loss, interference, and long-term troubleshooting nightmares. Now let's start with copper media. Now, this is the most common type of cabling in local area network. So copper cable transmit data using electrical signals. So the most widely used copper cables today is twisted pair Ethernet cable. Twisted pair cables contain pairs of wires twisted together to reduce electromagnetic interference, or EMI. So they are categorized into different categories. We've got Cat5e, Cat6, Cat6a, and a Cat7 and 8. Is there 8? I think there is an 8. I'm not gonna really talk about Cat 1, 2, 3, and 4, and 5. So those are obsolete. So each category supports different speeds and distance. For example, Cat5e supports up to 1 gigabit per second over 100 meters. So the cable must be 100 meters or less. While Cat6 and above support higher speeds and it has a reduced interference. Now, copper cabling is popular because it is flexible, it is affordable, and is very easy to install. However, it's susceptible to interference, and then it has distance limitations as well, and a signal degradation. Like I've already mentioned that you cannot go more than 100 meters, okay, with a twisted pair cable. Now, how about the connections? Now, copper network connections refer to how the copper cables are terminated and connected to devices. The most common connector used is RJ45 connector. RJ45 connectors are used for Ethernet connections, on switches and routers and network interface cards. And then copper cables can be straight through or crossover depending on how the wire pairs are arranged. Modern devices often support auto MDIX, which automatically detects the cable type. However, technicians must still understand the wiring standards such as T56A and T568B. So we'll actually, when we build the cables, maybe next week, I think next week Monday, we're gonna go to the lab and then I'll show you how to actually build the twisted pair cables. So incorrect termination is one of the most common causes of network failures. Now let's talk about building a copper cable, Ethernet cable. So this is a core hands-on skill for technicians. Building a cable involves stripping the outer jacket, arranging the wire pairs in the correct order, trimming them evenly, and then crimping the connector. These two main wiring standards, which is T56A and T56B. Both standards, they work, but consistency is critical. So if you mix the standards incorrect, it can result into a crossover cable or a broken connection. So after you crimp After crimping, cables must be tested using a cable tester. Testing verifies continuity and then correct pinouts and then signal integration as well. Integrity rather. So a cable that looks correct can still be faulty as well. Now, next we move into fiber optic media. Now, fiber cables transmit data using light instead of electricity. Remember, copper cables, they use electricity, so fiber uses light instead of electricity. So this makes fiber immune to electromagnetic interference. Fiber supports much higher speeds and longer distances than copper. Okay, remember, copper is 100 meters, fiber can be kilometers, can be miles. We actually have fiber cables running under the sea that connects us from Africa to Europe, Europe to Asia, and so on and so on. All right. Now, now there's two main types of fiber. There's single mode and there's a multi-mode. All right. Single mode fiber is used for a long distance communication, and then multi-mode is used for a shorter distance, like within building and data centers. Fiber is more expensive and is fragile than copper, but it is essential for modern high-speed networks. All right. Now, fiber network connections require precision and cleanliness. Common fiber connectors include LC, SC, and ST, and an MPO. Even a small amount of dust can disrupt the light transmission. Right? Fiber connections must properly be cleaned before installation. Right? Incorrect alignment or dirty connectors can cause signal loss as well. Unlike copper, fiber issues are often invisible to the naked eye. So the specialized tools that are used to test fiber links, including light meters and OTDRs and things like that. Now, transceivers are devices that convert electrical signal into optical signal and back again. So they are used in switches, they are used in routers, servers to connect fiber or high-speed copper links. So common transceivers types include SFP, there is SFP plus, QSFP. We're going to talk about all of those. So they define speed, they define distance and cable type compatibility. So if you're using a wrong transceiver, it can result in a link failure or reduce performance. So technicians must always verify vendor compatibility and specifications. So transceivers are not hot swappable, but they must still be handled carefully. Now, let's look at a scenario. Let's say you have a new office network that is installed, but users experience intermittent connectivity. So investigation reveals that cables running parallel to power lines, electrical interference is degrading the signal. So that means that you cannot put your Ethernet cables parallel to power lines, or you cannot put them on top of what you call these fluorescent lights, because those emit a lot of EMI or electromagnetic interference. So the solution will be to reroute cables and follow proper cabling standards. So this actually shows why media choice and installation practices matter. Now, just to summarize this section, media is how data is physically travels through the network, and then copper cable is flexible and affordable, but limited by distance and interference. And then fiber offers high speed and long distance, but requires precision. And then connectors and termination quality are critical as well. And then transceivers, they just a bridge devices and media. Strong physical layer skills just prevent most network problems before they can even start.